ground fault circuit interrupter, or GFCI, breaker will indeed sense a current imbalance between the ungrounded conductors and ground, even if the tub control panel does not require a neutral wire. Here's a detailed explanation of how this works. GFCI breakers are designed to protect against electrical shock by monitoring the current flowing in the circuit's hot and neutral wires. The key principle is that, under normal circumstances, the current flowing through the hot wire should be equal to the current returning through the neutral wire. If there is any difference, it indicates that some of the current is taking an unintended path, such as through a person or to ground, which can be a dangerous situation. If a fault occurs, such as a leak to ground, the current flow on the hot wire will become higher than the current flow on the neutral wire. This imbalance in current flow is what the GFCI breaker detects. The GFCI breaker contains a sensing transformer that continuously monitors the current balance between the hot and neutral conductors. This sensing transformer is essentially a donut-shaped core with the hot and neutral wires passing through it. When the currents are equal, the magnetic fields created by the two wires cancel each other out. However, if there is a difference in current, a net magnetic field is created, which induces a current in a sensing winding within the transformer. This induced current is then used to trigger the breaker to trip, interrupting the circuit and cutting off the power. In this specific scenario, the ground wire runs directly to the service panel, which is often referred to as a home run. This means that the ground current is not flowing through the breaker sensing transformer under normal conditions. The ground wire still provides a path for current to flow in the event of a ground fault. It's important to distinguish between the normal operation and a fault condition. During normal operation, the hot tub should draw current through the hot wire and return it through the neutral wire with minimal or no current flowing through the ground wire. However, if a ground fault occurs, current will flow from the hot wire through the tub's metal frame and into the ground wire. This will create an imbalance between the current flowing in the hot wire and the neutral wire. The GFCI breaker will detect this imbalance. Even though the ground wire is not directly connected to the breaker's sensing transformer under normal circumstances, a ground fault will still cause a current imbalance that the GFCI can detect. When a ground fault occurs, current will flow from the hot wire through the faulty component to the equipment grounding conductor, and then back to the source. This creates a difference between the current flowing in the hot wire and the current returning in the neutral wire. This difference is what the GFCI breaker detects and responds to. The GFCI breaker is designed to trip very quickly, typically within a fraction of a second, when it detects a current imbalance of 5 milliamps or more. This rapid response time is crucial to prevent electrical shock. The National Electrical Code, or NEC, requires GFCI protection for outlets and circuits that are located in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. Portable hot tubs fall under this category due to the presence of water and the potential for electrical hazards. Therefore, the GFCI breaker is essential for ensuring the safety of users. The fact that the hot tub control panel does not require a neutral connection does not affect the GFCI breaker's ability to detect ground faults. The GFCI breaker is primarily concerned with the balance between the hot and neutral wires, and any current flowing to ground will create an imbalance that the breaker will detect and respond to. The absence of a neutral connection in the control panel simply means that the hot tub's internal circuitry does not require a neutral conductor for its operation. The GFCI breaker still provides ground fault protection for the entire circuit, including the hot tub and its associated wiring. To summarize, the GFCI breaker will still be able to sense current imbalance between the ungrounded conductors and ground, even if the tub control panel does not require a neutral. The GFCI breaker monitors the current balance between the hot and neutral wires, and any current flowing to ground will create an imbalance that the breaker will detect and respond to, ensuring the safety of users. It's also important to note that proper grounding is crucial for the effective operation of a GFCI breaker. The ground wire provides a low impedance path for fault current to flow back to the source, which helps to ensure that the GFCI breaker trips quickly and reliably. Without a proper ground connection, the GFCI breaker may not be able to detect ground faults effectively, which could increase the risk of electrical shock. The installation of a GFCI protected circuit for a portable hot tub should always be performed by a qualified electrician who is familiar with the NEC requirements and local electrical codes. The electrician will ensure that the circuit is properly wired, grounded, and protected by a GFCI breaker of the appropriate rating. In addition, the electrician will verify that the GFCI breaker is functioning correctly by performing a test trip. To further elaborate on the practical implications, consider a scenario where the heating element within the hot tub develops a fault and comes into contact with the metal frame of the tub. Without GFCI protection, this could energize the entire metal frame, creating a significant risk of electrical shock for anyone who comes into contact with the tub and a grounded object such as a water faucet or a metal fence post. However, with GFCI protection, the fault current flowing from the heating element to the metal frame and then to ground would immediately create a current imbalance that the GFCI breaker would detect. The breaker would then trip, cutting off the power to the hot tub and preventing the electrical shock. The GFCI breaker's ability to detect small current imbalances is what makes it so effective at preventing electrical shock. Even a small amount of current flowing through the human body can be dangerous, especially in wet environments. The GFCI breaker is designed to trip at current levels that are well below the threshold for causing serious injury or death. In addition to protecting against electrical shock, GFCI breakers can also help to prevent electrical fires. Ground faults can sometimes cause excessive heat to build up in the wiring, which can ignite nearby combustible materials. By quickly interrupting the circuit when a ground fault occurs, the GFCI breaker can help to prevent this from happening. The NEC specifies the requirements for GFCI protection in various locations and applications. Article 210.8 covers GFCI protection for personnel, while Article 230.95 covers ground fault protection for equipment. These articles provide detailed guidance on where GFCI protection is required and the types of devices that are suitable for providing this protection. It is important to consult the NEC and local electrical codes to ensure that all electrical installations are in compliance with the applicable requirements. When selecting a GFCI breaker for a portable hot tub, it is important to choose one that is rated for the appropriate voltage and current. The breaker should also be listed by a recognized testing laboratory such as Underwriters Laboratories or Intertek to ensure that it meets the applicable safety standards. The amperage rating of the GFCI breaker should match the ampacity of the circuit conductors and the load requirements of the hot tub. In addition to the GFCI breaker, it is also important to use the correct type and size of wiring for the circuit. The wiring should be rated for the voltage and current of the circuit, and it should be suitable for the environment in which it will be installed. For example, if the wiring will be exposed to moisture, it should be rated for wet locations. The grounding conductor should also be properly sized and connected to the grounding electrode system to ensure that it provides a low impedance path for fault current to flow back to the source. Regular testing of the GFCI breaker is also important to ensure that it is functioning correctly. The breaker should be tested monthly by pressing the test button on the device. This will simulate a ground fault and cause the breaker to trip. If the breaker does not trip when the test button is pressed, it should be replaced immediately. GFCI receptacles can also be used to provide GFCI protection. These receptacles are similar to standard electrical outlets, but they have a built-in GFCI circuit that protects against ground faults. GFCI receptacles are often used in bathrooms, kitchens, and other areas where there is a high risk of electrical shock. They can be used to protect individual outlets or to protect an entire branch circuit. When installing a GFCI receptacle, it is important to follow the manufacturer's instructions carefully. The receptacle should be properly grounded and wired in accordance with the NEC and local electrical codes. It is also important to test the receptacle after it is installed to ensure that it is functioning correctly. In summary, GFCI protection is an essential safety feature for portable hot tubs and other electrical equipment that is used in wet environments. The GFCI breaker or receptacle monitors the current balance between the hot and neutral wires, and any current flowing to ground will create an imbalance that the device will detect and respond to, preventing electrical shock and electrical fires. Regular testing of the GFCI device is important to ensure that it is functioning correctly. And when you press the test button, it essentially shunts a small amount of current to ground, and if the GFCI is working, it will detect it, and it will trip. That is the whole idea of testing the GFCI, is you are confirming the functionality that is monitoring the current imbalance between hot and neutral and shunting to ground and confirming the trip.